Welcome to the next edition of Learning from Home with Mrs. Beckett. Today we're going to take a look at volume. And we're going to take a look at volume in a slightly different way because we're going to focus more on applications or word problems of volume questions. So let's start with a scenario that you might encounter. So Pilar and Amanda in the popcorn problem. I can't wait to see this movie. Me too. Let's get some popcorn. I'm starving. I want to get the largest size of popcorn. Me too. You have a choice of 2 containers for the same price. And the image shows a picture of a cylinder and of a rectangular prism. They both have the same height and they both have the same width across. I'm going to get the cylinder-shaped container. It looks like it holds more. Rectangular box for me, please. So who do you think you got more popcorn? I don't know. All I can think about is this yummy popcorn. So let's solve this problem. So if we go back to the original dimensions on the poster, we can see again that we have a cylinder with a diameter of 8 inches and a height of 10 inches. And we also have a rectangular prism with a width of 8 inches, a height of 10 inches, and a length of 6 inches. So what we're going to do is we're going to use the formula sheet that you have from your area and perimeter lesson, and we're going to use that to come up with the formulas and how to solve for the volume of these 2 shapes. So you may find it helpful to draw a picture of your objects. So we'll start with the cylinder. Actually, we'll start with the rectangular prism. All right, so we know that it has a width of 8 inches, it has a height of 10 inches, and it has a length of 6 inches. So just double check from our picture. Yep, that's exactly it. So then we're going to take a look at this. So if I look at the volume of a rectangular based prism, I know that the volume is length times width times height. So my 8 inches is going to be my width. My 10 inches is going to be my height, and my 6 inches will be my length in this case. So my volume is going to be 6 times 8 times 10. And you can multiply this all in one step using a calculator. So 6 times 8 times 10 is 480. And my units are inches cubed. So anytime I have volume, it's a 3-dimensional object, so it's a cubed as my units. So now let's compare that to the cylinder. So the cylinder has a height of 10 inches, and it has a diameter of 8 inches. So the 8 inches is the diameter, the 10 inches is our height. If I look at my formula sheet, my formula for the cylinder, the volume of a cylinder, is pi r squared h. Now I know the diameter of my cylinder, so I know that my radius is going to be half of that. So the radius is 8 divided by 2, or 4 inches. So now I can plug that into my volume formula for my cylinder. So I'm going to use 3.14 as my radius. As pi, or you can use your pi button. 4 is going to be your radius, so 4 squared times your 10 for your height. Make sure you're following order of operations, so we'll do our exponents first. So 4 squared, or 4 times 4, is 16. And now I can multiply all 3 of these numbers together. So 3.14 times 16 times 10. And I get a volume of 502.4, and my units are inches cubed. So now when I'm comparing my volume, I can see that in fact the cylinder had a larger volume than the rectangular prism. So I could write a therefore statement. Therefore, the cylinder will hold more popcorn. Awesome. Okay. So let's take a look at some more examples of some applications of volume. So what is the volume of the A-frame tent shown? So this A-frame tent is an example of a triangular base prism. So when I'm looking at my volume formula sheet, I can see that the volume of a triangular base prism is base times length times height divided by 2. So the way this works is that the base is going to be the bottom of your triangle. So that's going to be my 4 feet. The length on this one is actually the height of your triangle. So right here is my length of my triangle. So this is 4 feet. My height is going to be the height of that prism, which is 6 feet. You'll notice that it also labels 4.5 feet. This 4.5 feet refers to the slant height. And that's what we call just the diagonal line here that's related to my triangle. But I only need these 3 measurements for my volume. So the volume is my base, which is 4, times my length, which is also 4, times my height, which is 6. And I'm going to divide that by 2. I can simplify my numerator first. So 4 times 4 times 6 is 96. And then 96 divided by 2 is 48. And my units are feet. And because it's a 3-dimensional object and volume, I want to cube that. So because this is like a word problem, I can write a therefore statement in order to get full marks on a test or a quiz or an assignment. So therefore, the volume of the tent is 48 feet cubed. So remember, volume is what can fill up an object. Okay, and so this is important when you're going camping because you want to figure out how many people can comfortably fit inside of your tent. So the volume helps to figure out that as well. All right, next question. The Great Pyramid of Khufu in Egypt has a height of 450 feet. Each side of the square base has a length of 756 feet. What is the volume of the pyramid? So if a diagram is not given to you, you might want to draw a diagram if that's helpful for you to visualize that. So I'm going to start by drawing my square base. I'm going to draw it on a slight angle so it looks more like a parallelogram. And then I'm going to pick a point up here at the top and I'm going to draw a line from each corner of my square. So now I have my square base pyramid. So a square base pyramid, so all the sides on the bottom are going to be exactly the same length. So your length and your width are going to be the same. So it says each side of the square base has a length of 756 feet. So I can label that. I also know that I have a vertical height of 450 feet. So now that I have my diagram drawn and I've labeled my measurements, I can take a look at what my volume formula is. And it's probably easier to use the version of the formula that looks like this. So volume equals base squared times height divided by 3. So the base of my square base pyramid is my 756. My 450 is the height. So now that I've identified what those variables are, I can plug in the values into my equation. So the volume is equal to 756 squared, because it's going to be the area of your base, so length times width, or in this case, base times base, and then the times the height, which is 450. And then because I'm not filling up an entire prism, it's up to a point, I divide by 3. So that means that there are 3 pyramids that will fit inside of a rectangular base prism that has the same height. And that's a pretty cool experiment. If we were at school, we could actually take out some 3D shapes and we could fill them up, and we could see that exactly 3 pyramids will fit into a rectangular prism that has the same base and the same height. And it's pretty neat to see that. All right, so let's follow order of operations. So I'm going to do my exponent first. So 756 squared gives me a value of 571,536. I'm going to multiply that by 450 and divide that by 3. I'm going to multiply my numerator first. That gives me a really large number. And divide that by 3 to get my final answer. So I have an answer of 85,730,400, and my units are feet cubed. So now I can write a therefore statement. Therefore, the volume of the pyramid is 85,730,400 feet cubed. And that's pretty incredible, right? For the time when the pyramids were built. Fascinating. Okay. Let's go through another word problem. An icicle in the shape of a cone is hanging from a gutter. It is 13 inches long and has a radius of 1 inch. What is the volume of the icicle? Pretty fitting for this time of year. So let's start by drawing a cone or an icicle. So I'm going to start by drawing my circular base, and then I'm going to, from that circular base, draw it until it reaches a point. So here's my icicle. It is 13 inches long, so the entire vertical height of my cone is 13 inches. And it has a radius, so halfway across the width of my circle, of 1 inch. What is the volume of this icicle? So how much frozen ice do I have? So I'm going to start by taking a look at my volume formula from my formula sheet. The volume of a cone is pi r squared h divided by 3. I'm going to use 3.14 as pi, or you could use the pi button on your calculator. My radius is 1, so 1 squared. My height is 13, and I'm dividing this all by 3. Follow order of operations, so we must do our exponent first. So 3.14, 1 squared, or 1 times 1 is just 1 again. And now I'm going to simplify my numerator. So 3.14 times 1 times 13 is 40.82. And then I'm going to divide that answer by 3. If you have an answer that has lots of decimal places, like this one will, you can just keep one decimal place, so 13.6, instead of keeping all of the decimal places. And then you include your units, inches cubed for volume. So then we'll write our therefore statement. Therefore, the volume of the icicle is 13.6 inches cubed. Now we can also use volume, just like we did for composite shapes for area, and figure out the volume of composite shapes. So let's pretend that Packer has a doghouse. So there's Packer. He's going into his house. He's going around the back because the door is on the back side of this doghouse. And we want to figure out what the volume of space that he has inside of this doghouse. So we want to think about what shapes make up this entire house. So we have a triangular base prism for the top, and we have a rectangular prism for the bottom. So I have these two three-dimensional shapes that make up this entire house. So what I'm going to do is I'm going to calculate, in order to find the total volume, I'm going to find the volume of my triangular prism, and I'm going to add that to the volume of my rectangular prism. So just like we came up with a plan when we looked at area for composite shapes, we're also going to come up with a plan or a formula to figure out what the volume is of a composite shape, a three-dimensional shape. So I'm going to find the volume first of my triangular base prism. So I know that I have a base of 10 feet. I have a length. So this is my base right here. I have a length of 5 feet, and I have a height of 10 feet. So these are the, not 10 feet. I have a length of 12 feet. I'm using this measurement right there. So that's my length, and this is 12. So this 10 refers to this measurement right there. The 12 feet is the length or the height of my, let's call that an H instead, so we don't confuse it with the length here. So the H of 12 feet. So I'm going to calculate my formula. So I look at my formula sheet, base times length times height divided by 2. So my base is 10. My length is 5, and my height is 12, and I'm going to divide this by 2. So 10 times 5 times 12 is 600, and 600 divided by 2 is 300. My units are feet, and I want to cube that for volume. So now I have the volume of the triangular base prism. Now I can calculate the volume of my rectangular base prism. So the volume of a rectangular base prism is length times width times height. So I'm going to use 9 as my length. I'm going to use 10 as my width, and I'll use 12 as my height. This is a 2, not a 1. So I'm going to calculate 9 times 10 times 12. And I can do this all in my calculator. I can multiply all three of those numbers together. 9 times 10 times 12 is 1,080. And my units are feet cubed. So now that I have the volume of my rectangular base prism, now I can add those two together. So the total volume will be 300 plus 1,080 to give me a total volume of 1,380, and my units are feet cubed. So therefore, the volume of Packer's doghouse is 1,380 feet cubed. Awesome. Okay. So today, you're going to, instead of doing Knowledge Hook, you're going to work on an assignment that you're going to hand in. Okay, but part of this assignment also looks at converting between measurements within the metric system. And you might remember doing this in elementary school. So let's just do a quick recap of that. So when we're converting units between the metric system, we want to think about how many decimal points we need to move left or right, or how many powers of 10 we have to multiply or divide by to get to the next unit. So one thing that you might want to think about is the most common ones that we're going to look at. So we're going to maybe look at kilometers, and we're going to go all the way down to a millimeter. So kilometers are the large ones, millimeters are the smallest one. We have centimeters, we have decimeters, which we don't hear very often, but it's there. We have our regular unit, so our meter, liter, gram, whatever we're having to measure in. And then we're going to take a look at the decameter, which again, we don't hear very often. The hectometer, which again, we don't hear very often, but it's there. And then the kilometer. So within this chart, it tells you how many powers of 10 are inside here. So 1,000, 100, 10, 1, a tenth, a hundredth, and then a thousandth. One way to remember the prefixes for my units are the kind hungry ducks usually don't chew much. And so that will help you with that. So that's a little duck there to help you remember the units from kilometers down to millimeters. And also remember that if we are going from a smaller unit to a higher unit, we are going to be dividing, because our number is going to get smaller, by either powers of 10 or we're going to move our decimal place however many spots that we're moving to the left. If we are going from a larger number to a smaller number, it's actually getting bigger in terms of our number. And so we're going to multiply by how many powers of 10, or we're going to move our decimal place that many spots to the right. So an example of that, a plank of wood is 2 meters long. How many millimeters long is it? So we're starting with our 2 meters, and you can either put it into steps like we've done here, where we are multiplying by 10 first to get it into decameters. Then from there, we're multiplying it by 10 in order to get it into centimeters. And then from there, we're moving it in by 10 in order to get it to millimeters. Or another thing that you could have done is, because we are going from meters to millimeters, so I'm moving 1, 2, 3, I can times this by 10 to the exponent 3. Or we know, because we've looked at scientific notation, that this is the same as 10 times 1,000. And then that's going to be 2,000. So that's another way that you can think about it. Or another way that you can think about it is, here's my 2. Normally I would have a decimal point at the end of my number. And so when I'm thinking about this question, because I am going from a larger number, like a larger unit, to a smaller unit, I need to move my decimal place to the right, and I'm moving it 3 spots because that's how many units I'm moving. So it's going to go 1, 2, 3. There's my new decimal place. And inside of these like little egg cartons, I'm going to put my eggs or my zeros. So that becomes 2,000 millimeters. So different ways that you can approach this depending on what works best for you. So let's do a quick word problem associated with measurement conversions, and then I'll show you what you need to be working on in this lesson. So Layla wanted to buy a new tablecloth for her table, but forgot to measure it before she went to the store. So she texted her brother to ask him to measure it, but he decided to be annoying, like brothers always are, right? And gave her the measurements in different units. And so now we have to calculate the area of the tablecloth to figure out what size we need. And in order to do that, we need to convert these into the same unit. So you can either convert them into your larger unit or convert them into your smaller unit. It's probably easier to convert into our smaller unit in this case. So let's go ahead and convert kilometers into millimeters. Okay. But we also have to think about why would I convert this into millimeters though? Because I want to calculate my area in meters. So now I can relook at this question, and instead of converting it into my other unit, I'm going to convert it into meters. So if I look back at my chart, I know that to go from kilometers to meters, so I'm moving 1, 2, 3 units, okay? So when I'm moving from a larger unit to a smaller unit, I need to multiply. So I'm taking my 0.0022 and I'm timesing by 10 to the exponent 3. But 10 to the exponent 3 is 10 times 10 times 10. So I'm actually multiplying by 1,000. And I can just simply use my calculator for this, or I could move my decimal point, whatever is easier for you. And it gives me an answer of 2.2 meters. So I'm also going to do the same thing with my millimeters. So I'm going to change my millimeters into meters. So again, if I refer back to my chart, I can see that to go from millimeters to meters, I am moving 1, 2, 3 spots or 3 units, but I'm moving from a smaller unit to a larger unit. So I'm going to start with my 4,750, and now instead of timesing by 3 or 10 to the exponent 3, I'm actually going to divide by 10 to the exponent 3 because I'm going to be moving to a smaller unit or a smaller number with a larger unit. So I'm taking my 4,750 and I'm dividing by 1,000. And that gives me an answer of 4.75. And my units are meters. So now that I've converted both of these measurements into meters, now I can figure out what the area of my tablecloth will be. So the area of a rectangle is length times width. It doesn't matter which one you label which one. So the area is length times width, or the area is 2.2 times 4.75 which is 10.45 meters squared. So we'll end with a therefore statement. Therefore, the area of the tablecloth is 10.45 meters squared. If you feel like you need some additional practice for volume, some of you might be ready to get started on the assignment right away. You can. Otherwise, you're going to take a look at the Check Your Understanding questions. You're going to look at Part A, 1, 3, 4. Just do the volume only for 3 and 4. This worksheet also takes a look at surface area, which we'll be looking at in a future lesson, but just focus on just working on volume. And then Part B, for some more word problem or composite shapes, you're going to take a look at question 8, A and B, 10C, 15, and 16. So if you are taking a look at these Check Your Understanding questions and you get stuck, let me know, ask for help if needed, and check for your answers on Brightspace to make sure you're doing these questions correctly. If you feel like you are ready to tackle the assignment, you are welcome to do that. So your assignment will be posted on Brightspace. So if you have access to a printer, you can print out the assignment and do your calculations right on that assignment paper. Otherwise, you're going to answer your questions on a piece of lined paper that you're going to have at home. You're going to scan your work as a single PDF file using the OneDrive app. So refer to that video posted on the announcements from that first week that we looked at online. And then you're going to share it with me via email. So right from that OneDrive app, you can share it with me. Type in my either name and it might pop up, or you can type in the email address and share it with me that way. If you have any questions about this, please let me know, whether it's a question about scanning it and sharing it or a question from your assignment. Just hop onto Teams and let me know if you have any questions. And remember, you love math.